So the last thing we're going to look at today is 6.3 part 3. And this is on a couple things. First thing we're going to look at is graphing multi-step transformations. And there is a certain order you have to follow, okay, when you do them. It's the same order that we've been doing all year. And if you remember the letters I used for the transformations, I've already told you the order this week. Which transformation did I use A? That's the first transformation that you have to do. Yep. That's your horizontal or phase shift. Yep. I'll put that in parentheses. So always do your horizontal shift first. What transformation had the B? Yep. That's your horizontal stretch or your period change. The next transformation had the letter C. Which one was that? Yep.
Vertical stretch.
Yep, that's your vertical stretch or your amplitude change. And then which transformation had the D?
Vertical shift.
That's your vertical shift. Yep. So when you have multiple transformations, those are the order that we want to follow. And that's kind of like chemicals. If you don't follow that order, you could, not always, but you could get a different answer. So just stick with that one. Okay, any question on the order? So we'll try a couple multi-step problems. All that I'm interested in a multi-step problem is the final answer. Okay, that's all that I really am going to be grading when I grade it. So let's look at this one. 2 sine x plus pi over 2. Yeah.
I was curious because I know in the past when you do transformations, you have a little, I don't know how to say it, but you usually draw the equation, not draw the equation, but you write the equation with like
all
A, B,
letters?
C, D.
Yeah.
Yeah, I love having that.
So that's your phase shift, 1, period change, 2, amplitude or vertical stretch, 3, and D, vertical shift. Yeah.
I didn't really thought about this. Why is the shift before the stretch?
I don't know if that helps. Yeah. Why is the shift before the stretch?
Or well, I guess it makes sense. Yeah, because the shift doesn't get affected by the stretch.
So you're talking about the part inside the
Yeah,
parentheses?
it doesn't get affected by the stretch because the stretch is just the x itself.
Yeah, it's kind of like if you were solving an equation that had a number, a letter, and then plus a number. What's the first thing you would do here? Would you divide by the 3 or would you minus the 5?
Minus 5.
You would minus the 5. So you want to deal with this first.
Oh, that's why we do everything backwards, right? Like why we divide by a number instead of multiplying by it is because you're basically just like solving it algebraically.
Yeah, that's how you can think of what's happening inside here. Yep. Yep. That's kind of how that works. Yeah. So any other questions on the steps? Okay. So let's look at number 2. Or example 1. 2 sine x plus pi over 2. How many transformations does example 1 have? It does have 2. Can anybody tell me which 2?
Vertical stretch.
Definitely has the vertical stretch.
Phase shift.
And it has the phase shift. So we're going to do the phase shift first, and then we're going to do the vertical stretch second. Now, technically, this is a problem where if you switch the order, it would still be fine. But I don't really want to get into like when can you break the rules and do it in a different order and when can you can't. I would just say follow this order, and you'll never go wrong. Okay? All right, so let's start with the phase shift. All right, so let's make a table. Now, normally I would write down the values that are going to stay the same. Nothing's going to stay the same. The x's and the y's are going to change. Okay. So let's put the x's off to the side. Pi over 2, pi, 3 pi over 2, 2 pi. And put the y's off to the side. Don't put anything in the final table. What are my original y's for sine?
0, 1, 0, negative 1, 0.
Yep, 0, 1, 0, negative 1, and 0. There. Okay. So now, let's start with the phase shift. What am I going to do to all those x values?
Subtract pi over 2.
Right, we have to do the opposite. So we're going to minus pi over 2 from all of them. Okay, hopefully we've been working with them enough, we can kind of figure them out pretty quick. If we need to do common denominators, we can. But hopefully we're kind of past that. But let's just kind of go through it. What's 0 minus pi over 2? So negative pi over 2. Pi over 2 minus pi over 2 is 0. How about pi over 1 minus pi over 2? It's pi over 2. 3 pi over 2, take away 1 pi over 2. Yeah, that's 2 pi over 2, which is just pi. And what about 2 pi over 1 minus pi over 2? 3 pi over 2. Yep. So any questions on the x values? Well, those are the harder ones for this. But actually, they're the harder ones for any problem.
I mean, they're really just increments of pi over 2.
Yeah, they're all increments of pi over 2, just starting at negative 1 pi over 2. Yep. Okay, so now we've got the x's. Now, what am I going to do to all these y values? Right, you're going to vertical stretch by a factor of 2. So multiply them all by 2. All right, so what's going to be my new y values for the final answer? Yep.
0, 2, 0, negative 2, 0.
Perfect. And what's inside that box for the table, that's what I would be grading. So you get 1 point for each x and y value. Any questions on the table? Now the graph, well, just like we always do, graph is pretty easy. The highest y value is 2, and the lowest is negative 2. So what I would do is put your graph back on the page. I'm going to scale my axes on the y to go by 2. And then on the x's, I'm going to use the labels in my table. So negative pi over 2, 0. Axis always has to be 0. You can't change that. So that's 0. Pi. And 3 pi over 2. All right, let's graph them. Okay, so negative pi over 2, we are at 0. 0, you're going to go up to 2. Pi over 2, back to 0. Pi, you're going to go down 2. And 3 pi over 2, back to 0. And there's your graph. Now, it doesn't look any taller than a normal graph. How come? Because I scaled it. I went by 2, so that's why it doesn't look taller. But you can tell it's been shifted to the left. Yep.
How's the graphing going to look on the test?
The graphing will either be ones where you just have to plot, like you'll just click on the coordinate and put the points, or I might give you some where you have to just match the equation to the picture.
Okay.
Yeah.
Would we be able to scale it like that? Or?
If it's ones where you would have to like plot the points yourself, I would probably set up the scale for you.
Okay.
So it would already say 2, 0, negative 2,
Okay.
if it was like that.
Is the table going to be like a multiple choice, like drop down for each?
No, the table is just going to have 10 blanks.
Alright.
and you'll just have to click in each blank and then type it in. And you'll be able to type in the pi symbol, because when you click in the box, the pi symbol will come up. And the fraction, you guys have seen that button before. So the fraction button will come up to do fractions. Yep. Okay. Any other questions on that? All right. Let's try this one. So it says 3 cosine 2x. All right. Let's start with the 2. I always start inside the parentheses. What kind of transformation is the 2? Horizontal what? Yep. It's a horizontal. It could be a stretch or a shrink. In this case, it is a compression. Yep. Okay, so let's put our x's off to the side. And we're supposed to take all of these x values and divide them by what?
2.
Divide them by 2, which is the same as multiplying by 1/2. So I don't know, I just think multiplying is easier. So let's just multiply by 1/2. Okay. First one, 0 times 1/2 gives me 0. What's pi over 2 times 1/2? Yeah, multiply straight across. Pi over 4. And then pi times 1/2. That's pi over 2. The next one, 3 pi over 4. And then half of 2 pi. 1 pi. Okay. And again, it doesn't look like they're equally spaced, but if they all have denominators of 4, 0 pi over 4, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. Right. And that's your x's, and you get 5 points for that one. All right, now the y's. Okay, put the originals. And what's going to happen to the y's this time? They're all going to get multiplied by 3. Okay, so what are my final y's?
3, 0, 3.
Yep. There you go. Any questions on the table? All right, so now the sketch. So this time I'm going to scale my y's to go from -3 to 3. My x's are going to use the labels in the table. 0, pi over 4, pi over 2, 3 pi over 4, and yeah, pi. Okay, so we got our x's. 3, 0, -3, 0, 3. All right. So 3, 0, -3, 0, and 3. Okay, again, it's not going to look like a vertical stretch because we changed the scale. It also doesn't look like a horizontal stretch because we changed the scale. It looks like the regular V shape we always do, but the scale has changed. Question on that one? Now, I told you to always follow that order. Technically, in these last two problems, you could have not followed the order, and it would have still been okay. But just follow the order. All right. Let's do one where if you don't follow the order, it would mess you up. Let's do 2 sine x plus 3. All right. What's the 2 going to do? Yep, that's a vertical stretch. And what's the 3 going to do? Vertical shift. Vertical stretch, vertical shift. That's why the order matters. You're doing 2 things that are vertical now. If you're still not sure why it matters, think of a number in your head. Double it and add 3. Now do it the other way. add 3 and double it, it doesn't always come out the same. So we have to do the doubling and the adding 3 in the right order. So we're going to do the vertical stretch first, and then the shift. So one of the columns this time isn't changing. Which column is not affected at all in this problem?
X.
Yeah, the x's. We're not doing a horizontal in this problem. So 0, pi over 2, 2 pi. Okay, write down the original y's. 0, 1, 0, -1, 0. And we need to do the stretch first. So what does that mean we need to do to the y values first? We have to multiply by 2 first. Alright, so we're going to first multiply them by 2. And then what do we do after? Then we add 3. I put the parentheses there to clarify what we're doing first. Okay. All right, so what's the first one? 0 times 2 plus 3. So we get 3. 1 times 2 plus 3? 5. The next one?
3.
Okay. And the next one, that's a -1. That's going to give you -2 plus 3, which is 1. And the last one? Back to 3. So 3, 5, 3, 1, 3. Those are your y's. Is there any question on how you would do the graph? The big thing I just wanted you to make sure is you do the double first and then add after. Okay, so just always follow the order. Okay, questions up? Okay. So I have a question then. Why is that not a phase shift? I thought, or a horizontal shift. I thought if you did plus a number, it was a horizontal shift.
Because it's outside of the parentheses.
Yeah, it's not grouped with the x. That's a totally different problem now. Okay. If you don't group the letter and the number together, then it's not a phase shift. All right. So let's try this one. Find a complete graph. That means on the calculator. You do not have to sketch it by hand. You don't have to make a table. So they want us to find a complete graph and then find the domain, the range, the amplitude, and the period. It's actually easier to find these things first, some of them, because then it tells you how to set your window on the calculator. Let's start with the domain. Domain describes which way? Is that like x values or y values? X values, yeah. Domain describes left and right. Picture the sine and cosine function. How far left and right do they go? Infinite. So what would we say the domain is? Yeah, negative infinity to infinity, all real numbers. Every single sine and cosine function has a domain of all real numbers. They go forever left and right. They do not go forever up and down. They stop. Right? That's the next step, the range. If you had a normal sine function that don't do anything to it, how high would it go? And how low? -1. Is there any number here that's going to change how high and low it goes? 4. The 4. This is a vertical stretch. It's a vertical stretch by 4. So if the range was -1 to 1 and you stretch it 4 times as much, what would it be? -4 to 4. Yep. So the only thing that can affect the range is if you do a vertical stretch or if you do a vertical shift. Okay. But there was no vertical shift in this problem. All right, so we got the domain, we've got the range. Amplitude, that's something we talked about yesterday. What's the amplitude of this? The 3 doesn't have anything to do with the amplitude because that's a horizontal thing. 3 is a horizontal number. Yeah.
4.
The amplitude is 4. Yes. Remember, the amplitude is the absolute value of the number in front. And for the period, what when you write it as a fraction, what number always goes in the top?
5.
2 pi. And what goes in the bottom? B, which in this case is 3. So those are all the things they wanted you to find. You really don't need a calculator to do those. Okay, now we need a calculator because we want to graph it. All right, so first thing, when we describe the period is a length. It's a length. It's the x-axis, and the x-axis is measured as an angle. 2 pi over 3. What are the units on that? That's in radians. Okay, the period is always, and it represents a length as like how far you travel on the x-axis, and the x-axis is an angle. So if that's in radians, then I need to make sure my calculator is in radians. Okay? If instead of 2 pi over 3, you put 120 degrees, that is correct. But that's the period in degrees. Okay? We usually do the period in radians. Just that's how we do it. Okay, so I'm already in radians. If you're not, you need to press mode. You need to go down to where it says radians and put it on radians. And then hit enter. If it says degrees at the top, you are not in radians. So you need to fix that. All right, now we type it in. So 4 sine 3x. How high and low does the graph go? Okay, it does -4 to 4, so I don't really need -10 to 10. I think -5 to 5 on the y-axis is fine. So just put -5 to 5. Okay, I messed that up a little. All right, now the x's. It's always good if you show at least one period, okay, one full cycle. How long is one cycle of this graph?
2 pi over 3.
One cycle is 2 pi over 3 radians long. So the easiest way to set up a screen that's exactly 2 pi over 3 radians long is start at 0 and end at 2 pi over 3. When you type 2 pi over 3 in, it will then change it to a decimal for you. All right, now if you put everything in the way I did, and you hit graph, you should see a perfect graph of one cycle, just like that. So it did say to find a complete graph, so I would write down the min and maxes. Remember, that one was 2 pi over 3. Now, what if I wanted to see, that's one cycle. What if I wanted to see 2 full cycles on the screen? How long would 2 cycles be? It would be double the length of one cycle. Okay, one cycle is 2 pi over 3. Let's set it to 4. Set it to 4 pi over 3. Now, by setting the window twice as big, you should see twice as many cycles. So there's one cycle, and there's exactly 2. Perfect. There's no rule how many cycles you really have to show, other than I would say make sure you show at least 1. But you don't need to show like 10. 1 or 2 is fine. Any questions on that one? Okay. Alright, so find a complete graph and domain, range, period, and amplitude. Okay, another sine function. What's the domain? Yep, all real numbers. Okay, so now the range. Think about what the range would be originally, and then look if there's a vertical stretch or a vertical shift. Those are the only two things that affect the range. Do I have a vertical stretch in this problem?
Yes.
Yes, then I need to do that first. Normally we would go -1 to 1. What's that 3 going to do? Times it by 3. So we're going to go from
-3 to 3.
-3 to 3. Now you still need to check if you shifted it. Is there a shift here?
Yes.
Well, for the range. No. Let's say there was a shift up 1. Well, if there was a shift up 1, then I would just take -3 to 3 and move it up 1. It would be -2 to 4. Let's shift it up. Okay, but there's no shift. All right, so we got the domain, we've got the range. How about the amplitude? Yep, the amplitude is going to be 3. It's the absolute value of the number in front. And what about period? Always start with what goes in the top. 2 pi in the top. What goes in the bottom? 1. So there was no period change in this one. There's no horizontal stretch or compression. All right, so let's find a complete graph. Let's do 3 sine, x minus 1. Okay, and as far as a window, well, I can leave it -5 to 5. It's only going to go -3 to 3, but that's fine. And if I want to make sure that I show at least one cycle, how big does my window have to be? 2 pi. So I'm going to do 4 pi. I want to show 2 cycles. So it started down here. It should end right down there too. Because if you show exactly 2 full cycles, it needs to end where it started. So there's 2 cycles. Okay, looks a little bit different than what we normally do for sine because of that shift amount. It shifted by 1 radian to the right. But I'm not worried about you making a table or anything like that. Okay, any question on that? So just don't forget to write down your x min, x max, y min, y max. And that x max was 4 pi. Questions on that? Okay. All right, so the last thing we're going to look at, it's really something we've done before, is solving trig equations on the calculator. Now, we haven't solved the trig equation, but we have solved equations by putting something in y1 and y2 and then calculating something. That's what we're going to do here. So, to solve a trig equation, well, let me show you something first. So watch how long it took me to do this. That's one of the answers to the problem. Okay? I'm going to show you how to do that eventually. And I'm going to show you how to do this. That's the other answer to this problem. So there's a way to do what we're doing here without graphing. Okay? You have to know a little bit more about what's called inverse trig. So we're going to talk about that. And you have to know, why did I do pi minus something? Like, where did that come from? Well, I'm going to have to show you that at some point. But for now, we're going to graph. What I want you to kind of watch, though, is how long it took me to do that, maybe 4 or 5 seconds, compared to how long it's going to take to do it graphically. Graphically, it's going to take a lot longer. Right. But it'll still give you the same answer, and for now, it's an easier way to do it. Just not the fastest. All right. So So what do you think I have to put in y1 if I want to solve this problem? Sine of x. So we put that in y1. Now at this point, I would have already had one of the answers if I don't use a graphing calculator. Okay, so it is slower. What would go in y2?
0.4.
0.4. Now, when you put y equals and you put in a number, what does the graph look like when it's just a number on the other side? It's just a straight line. So what you're going to have is, you're going to have, actually, let me do it like this. You're going to have the graph of sine. Okay. So that just keeps going. And you're going to have a straight line at 0.4. So how many times will the line and the wave cross? Right, they're going to cross infinitely many times, but they don't want infinitely many answers. They're telling you where they want the answer to be. Where do they want the answer to be?
Within the first period.
Yeah, right, even the first period. They want it to be between 0 and 2 pi. So they are looking for the answers right there. That's what that means. And again, keep in mind these two numbers, 0.41 and 2.7, and let's see what happens. So to get the answers in the first period, you need to set your window to the first period, 0 to 2 pi. So 0 to 2 pi. And how high and low is the graph of sine going to go?
1 and -1.
Yes, I don't really need -5 to 5. I would say just do like -2 to 2. So now hit graph, and you should see a picture of pretty much what I circled. Just the first cycle. All right, so now we got our graph. And what do you think I have to calculate now? Got to calculate the intersect, and how many are there?
2.
Going to be 2. So the second calc, intersect. Okay, I'm going to do the one on the left first. So because there's 2 of them, is the guess important?
Yes.
Yes, it is. You got to make sure that you move it closer to the one you want. And there is your first answer, 0.411. Okay, and that's exactly what I had doing it without a graph, 0.411. Now the second answer. The second answer, the calculator doesn't give me the way I did it. I had to know to subtract the first answer from pi. I'm going to teach you how to do that later on. For now, just go back to your graph, do second calc, do intersect again. And we get 2.7300. Is that the answer that I got before? Yeah, it's the same thing. Okay. So you might just say, well, why don't we just get the first answer like you did and subtract it from pi, because it's not always subtract from pi. Sometimes it's add to pi. There's different rules. So we're not really learning those rules today. We're just graphing it and doing 2 intersections, and that's it. Yep.
Is it because pi is half this period?
No, it involves a little bit more. Yeah. There's a diagram I'm going to eventually teach you that has to do with where the different trig functions are positive in the different quadrants, all, sine, tangent, cosine. So I'll teach you that diagram, and then it'll make more sense. Yeah.
So the second problem kind of shows you where to put your like your x values in the calculator for like where the first section is going to be. Like if it was
Yeah, it's your window.
Okay, so that's the window.
It's the window. Yep. And the window is usually 0 to 2 pi. It doesn't have to be.
Okay.
Technically, it could be any window they want. They could have you find the answers, way down, but usually they don't. All right, let's try it out. Let's try another one. So 2 cosine 1/2 x equals 1.5. And notice the way these intervals are written. One of them has the equal to, the other one does not. That's because when you draw something, if you count this as an answer, you don't count this as an answer too, if you're looking for where they cross. Because technically, this is the start of the next cycle. So you only include one edge of the window. Right? Don't include both. Think of it as like this is 0, this is 360. 0 and 360 are the same thing. So if you include 0, you can't include 360. You can include 359.999. But you can't go to 360 because that's the start of the next cycle. Any question on that idea? That's why I've been writing it like that. All right, now they want us to see where the cosine graph is going to hit 1.5. Does cosine ever hit 1.5? What do you think? If you just draw a regular cosine, would it hit 1.5?
No.
No, it would only hit what?
1.
1. So yeah, negative 1 to 1. So is that going to be a problem here?
No.
No, why not?
It's vertical stretch.
Because it has a vertical stretch. So this is not going to go from negative 1 to 1. It's going to go negative 2 to 2. So it will hit 1.5. If that 2 wasn't there, then this would be a no solution. Cosine would never hit 1.5. But with the 2, it will. Okay, so what are we going to put in y1? What is it? 2 cosine. And just so I don't have to use another fraction, I'm going to just put 0.5x. And then what's going to go on y2? 1.5. Now for my x's, it's the same window as last time, so I don't need to change it. Is negative 2 to 2 going to work for my range? Yeah. I only have to look at 1.5. That's in negative 2 to 2. So hit graph. Again, it's right on the edge of the screen on the top and the bottom, but I don't really care about that. All I care about is, can I see where they cross? And yes, I can. How many times do they cross in that window? Once. There's only going to be one answer. Are there other answers outside that window? Oh yeah, there's more over here and that way, but that's not what they want. So this time we get 1.45. When you write it, you should use the approximate symbol because it's an estimate. It's not the exact answer. Now, another thing I should mention, when you look at your window, or when you look at this, it not only tells you your window, it tells you your mode. How do you know that this is radian mode? Or another question, what would be written here if this was degree mode? You would, well, not just 360, but degrees. And this would have said 0 degrees. So if it has a degree symbol, then you know you're supposed to be in degrees. If it doesn't, you're supposed to be in radians. All right. Any question on that? Okay, so let's do it in degrees, in case there is one on the test that asks you to do that. Well, instead of 0 to 2 pi, just change it 0 to 360. And there's one other change I have to do. Change my mode. Now there shouldn't be any difference in the picture. The picture should look identical to what you just did. Because you change the window and you change the mode, you're going to get the same picture. But we're not going to get the same answer. This is an answer in radians. Now if we do it, we're going to get an answer in degrees. So second, calc, intersect. And sometimes when you do it in degrees, you get a nice answer. Where radians sometimes gives you kind of a messy answer. Let's see. Well, I still didn't get a nice answer. It's 82.82. So which answer is correct? Well, in this problem, because they gave you radians to start, I would say you should give the answer in radians. If they give you degrees to start, give the answer in degrees. So 1.45 is technically the correct answer for this one. Okay, any question on that? All right, let's try this one. It's pretty similar, a little bit different. What's different about it compared to the last two?
It's an inequality.
Yeah, it's an inequality. Still have to graph something in y1 and y2. You still have to calculate an intersection. The only difference is when you write your final answer, it's not just a number. It's an interval, like between this and this. All right, so let's graph it first and just see what we're looking at. So we get 2 cosine x and negative 1.3. Okay, x value is 0 to 2 pi, so we don't have to worry about changing the window for the x's. And I think the window, oh no, I do need to fix my window. What do I need to fix? That's not going to work at all. Yeah.
You need to go back into radians.
I got to go back to radians. So 2 pi and radians. All right, so now I'm 0 to 2 pi and negative 2 to 2 for the y's. That's going to be fine. Is there any question why I knew I had to go back to radians? Those aren't degrees. They don't have the little circle. Okay, so let's hit graph. And we're looking for where the wave is above the horizontal line at negative 1.3. Okay, so let's look at that. First of all, is the wave ever above the horizontal line? Yes, it is. How many pieces do we have to break the wave into that are above the line? There are two. 2 pieces. Okay, we'll call this one piece 1, and this one piece 2. I need to describe both of those pieces. All right, let's start with piece 1. Piece 1 goes from here up to here. So you need to describe that section to me. Where does piece 1 start?
0.
It starts at 0. That's the leftmost point. Remember, you're describing the x value. So it starts at 0. Can I include or not include 0? I can include it. Has it equal to? So I can include 0. And then how do I figure out where interval 1 stops? I need to find the intersect. So find that intersect. This time the guess does matter because there's more than one. Okay, so it stops at 2.28. That's where interval 1 stops. Now, can I include 2.28
Yes.
or not include?
No.
No, I can't include it because it doesn't say that these graphs can be equal to each other. It says the wave has to be greater, has to be above. So don't include where they hit. 2.28. And then we have a second section. Now we have to describe from here to here. Okay. What symbol do we use when you have another section? Yep. So or. Now, how are we going to figure out where section 2 starts? We're going to do the intersect again. So second calc, intersect. All right, so we'll get that. It's 4.00. Can I include 4.00 or no? No, I can't include it because, again, they cannot be equal. The wave has to be above. So I'm not including. And then where does interval 2 stop? It stops at the edge of my screen, 2 pi. Can I include or not include 2 pi? Not include, because remember, the edge of this window is a repeat of the edge of that window. They're the same thing. So really, the right edge of this window is the next cycle. It doesn't go with this one. And that's how you write your answer. So very similar to an equation. You still have to find the intersect. You still have to graph it. You still got to do all that stuff. Just write your answer as an interval. Yeah.
So it would never say less than or equal to 2 pi, because you would never include it?
No, that's like including 0 and 360. They're the same thing, so you don't want to, that's a duplicate answer. Yeah. Yep. Okay, any other questions? Okay, so let me put up the homework. I think I'll have time to do the topics in the video too.
How many questions do you have?
Let me check. Okay, I might adjust that. So just give me a second. I'm just going to change these two. So 14, 16, and 18. Okay, for 29 to 31, you don't have to do what they're saying. They're what we just did on the graphing calculator. You do need a graphing calculator though. So solve on graphing calculator. And yeah, everything else looks good.